Hi everyone. In this video, I'm going to talk about our last module, which is module 17 of the ITN course. Here we are going to summarize all the things that we have learned in our previous modules, and we will find out the tips and tricks of troubleshooting a network. What are the different tools that we have, how to use the different commands that we learned in our earlier modules. So our ultimate goal as a network administrator should be that once you set up a network, and you should be able to troubleshoot if any problems arise. So let's see in this module what we're going to cover in this module. Our last module is module 17, where, as I said, we will be just discussing about what are the different issues that need to be taken into consideration while planning and building a small network. So here are the different topics or the what are the things that we're going to cover in this particular module. We are going to study about what are the issues related to scaling of networks, how do you verify connectivity, what are the different iOS commands that we can use, what are the different troubleshooting methodologies and the scenarios. To start with, first of all, let's talk about a small network. Why should we bother about a small network? As you most of you are aware, the majority of the businesses are small and hence they deal with small networks. Usually, small networks have a single wide area connection by a cable network or an Ethernet connection. Whereas comparatively larger networks require an IT department, a network administrator to maintain, secure the devices, to troubleshoot the network devices, and their primary responsibility will be to safeguard the organization data. Contrastingly, smaller networks, you have maybe one or two technicians to handle the network issues, or maybe a third party, a contractor professional to come in and set up your network and take care of it. So device selection for a small network also plays a crucial role because you have to plan carefully and design it according to the requirements of the users. So there are different factors that should be taken care of when you are selecting a network and you are designing it based on the requirements. The first thing, foremost thing is cost. The budget plays a crucial role because you have many devices, many network devices in all budget ranges. So which suits you better? What is its capacity? What is the features that it should have? How many users you are going to have in your network? All those things do come into play. Next thing is the speed that you need and the different types of ports and interfaces that are required. Expandability, this is a scalability thing, whether you need a modular one or a fixed one, the type of device I'm talking about. And finally, what is the required operating system features and services. So all these factors must be taken into consideration when you are selecting the network device and also while you are planning itself, because you don't want to just buy the stuff, put it in and then see if it doesn't work or if it doesn't suit your requirements, you can't change it. So careful planning must be implemented first. In that, device selection plays a crucial role. Okay, then comes the IP addressing. We have studied in our module 6 and in our earlier modules about IP addressing. So you have to carefully plan a network. You once you have your IP address, you can subnet it also. Generally, in a sense, a network administrator, what he does is he takes into consideration what are the end user devices, what are the servers or peripheral devices, and also what are the intermediary devices, which includes your switches and access points and routers. So all these things need to be taken into consideration, and then he has to design an IP addressing scheme which satisfies the needs and which makes it easier to assign these particular addresses to these devices. And once again, once you do this, it is always recommended that you plan, document, and the addressing scheme should be on the device type. So all the, let us say that all the end systems like your normal PCs will have one particular series of IP addresses. The reason why I say it should be planned or should be carefully planned is because it becomes much more easier to identify the type of device, and at all if there is a troubleshooting, if the problem arises, troubleshooting becomes that much easier when you know by looking at the address and you can identify the type of device. If I say that maybe dot ones or dot twos, the starting point of the first address of a particular subnet, I know that it is the default gateway. Like in that sense, it's easier if you implement the IP addressing in that manner. Redundancy also plays a crucial role. We already studied this. So redundancy, the main objective is it eliminates single point of failure. So in order to accomplish this redundancy, what we need to do is we need to install duplicate equipment so that there is always an alternative path for the network traffic to pass through. And in case if one particular device or one particular system fails, it should not bring down the entire network. That is the reason network administrators always include redundancy in their network. They always want to have some alternative if something goes down. Okay, so that is why all redundancy also should be planned. Next comes traffic management. So when you're planning for the devices in traffic management, you can't say that all the traffic are the same. Obviously, there will be high priority traffic like voice, live streaming, and then comes SMTP traffic, which is medium priority. Then comes instant messaging or FTP type of traffic. So in order to achieve this type of traffic, quality of service should be implemented. The best way of doing it is queuing, so that whenever traffic comes in, based on the priority of the traffic, it is emptied first. So rather than issuing the same priority to all type of traffic, we can issue these priorities based on the requirements, so that the quality of service can be maintained. And if a packet with high priority comes in, just like a live messaging or live interaction, that particular packet should be sent first rather than a packet of an email. We have studied quality of service. Similarly, we have to implement that quality of service also. Let's talk about the applications and protocols in a small network. So what do you mean? Usually, we have two types of applications. One of them is network applications, which implement your application layer protocols that we studied, HTTP, SMTP, all those things, and they are able to communicate directly with the lower levels of the protocol stack. The other category are your application layer services. They are not network aware. They actually these interface with the network, and they just prepare the data for transfer. That comes under your two categories of applications, which is your network application and application layer services. So I'm just showing you the list of the different protocols that are most commonly used by your users. You have studied this in our application layer module also. We are talking about SSH, HTTP, HTTPS, SMTP, POP3, IMAP, FTP, SFTP, DHCP, and DNS. We studied these things in our application layer module. We discussed about how they are used and what is their purpose. The same thing. These are the most common protocols. And once again comes our voice and video applications. With the advent of internet daily, most of the people are now streaming, and it is done through online mode, virtual mode, work from home, all these things, where voice and video applications plays a crucial role. For this, an administrator should plan accordingly. If your network needs to support these type of applications, you have to make sure that you have the relevant protocols in place, relevant bandwidth is in place, and better go for VoIP. Voice or IP is typically less expensive. IP telephony also can give you good features, and you have to maintain the infrastructure. The bandwidth should be good. Everything should be good. So priority delivery is important for such applications, and it is the responsibility of the network administrator to ensure proper equipment and infrastructure is installed, and the network devices are configured also properly to handle such priority traffic. Okay. And next comes scalability. Scalability means if growth is, you can't stop growth. Networks keep on growing every day. So in order to support such growth from the network point of view, scalability will become an issue. So for that, network documentation has to be done very neatly. So administrator should understand what is a physical topology, what is your logical topology, what are all the devices that you have, inventory, budget, itemized IT budget, equipment, purchasing budget, and the most important thing is traffic analysis. The protocols, applications, and services and their respective traffic requirements should be documented properly. So all of these things put together will help the decision making process regarding the scaling of small networks. So not just one or two things are required here. You need to have a comprehensive idea on all these things. As I told you, growth is a natural process. You can't just have only one thing over here. It has to be, the small business keep on growing every day. So scalability will also be at the top of the priority for a network administrator. How does the network scale? So all these things need to be taken into consideration. Next thing is flow pattern protocol analysis. So what is you mean by traffic analysis? Means that you should be, the network administrator should have a good idea about what type of traffic, what is the amount of traffic, what is which protocol traffic, all these types of traffic are passing through the network at what points of time, what will be the current flow. So for that, what he can do is he can actually capture traffic during peak utilization times to get a good representation, and not just on one particular network segment, on different LAN segments, to make sure which particular segment is creating what type of traffic. Information gathered by the protocol analyzer is evaluated based on the source and destination of the traffic, and also type of traffic being sent. Then based on all this analysis, based on all the traffic captures, it can be used to decide how the management should proceed, or how to manage the traffic in a much more efficient manner. This should also be done under protocol analysis. How would an employee network utilization? So everybody is not the same. Some people use network more, some people might use it less. All these things do happen. So snapshot of the following, and you can say that whenever you want to find such things, it is always going to help you to take a snapshot. What do you mean by snapshot? All the information which is written over there, OS and OS version, CPU utilization, RAM utilization, drive utilization, what are the different non-network applications that are being used. So when you document such things for employees in a small network, it is very useful to identify the protocol requirements and their associated traffic flows. The traffic analysis, which we discussed in the earlier slide, goes hand in hand with this particular network utilization. Now, when you do this, when you find that there is a shift in the resource utilization, it will help the network administrator to adjust the network resource allocations accordingly to meet the requirements and needs of the users. So how can you get it? By getting snapshots, by doing this traffic analysis, by understanding what the users require. Then comes verify network connectivity. So you, whether irrespective whether your network is small, new, large, you should always be able to verify whether the components are properly connected to one another and to the internet, whether they are able to talk to one another. For that we have the ping command. We have done a lot of packet tracer activities for this particular ping command in our earlier modules. It uses, we all know that it uses the ICMP echo and reply messages. So ping should be used. So ping is actually, it is a type of command. It tells you just whether the destination host is reachable or not. It is an effective way to quickly test the layer 3 connectivity between your intended destination. We have another option called as extended ping. If you can see in this figure over here, in your mode, in the privileged executive mode, you can just type in ping and press enter. It gives you all the list of different options that are there. The target IP address, count. It if to understand better, what it does is your iOS gives you different prompts to customize this extended ping so that to have a better control on what you're trying to test here. Okay, you can try this also. Extended ping is there. The next other tool that we use extensively is traceroute. You know that how traceroute is used, and it gives you an idea whether how many hops are required to reach the destination. This also will help you to locate the problems that happen in your layer 3. This trace returns a list of hops as a packet is routed through a network. The syntax actually helps you. We did this earlier itself. You know that if there are dots or stars and an asterisk, that means that there is a problem. It identifies that it is not reachable. Whatever the destination you're trying to do is unreachable. Whereas the other, it shows you the amount of time that requires. We've done a lot of activities on traceroute. And once again, we have something called as extended traceroute also. If you want to have a quick overview on extended traceroute, what I suggest you to do is you can actually just type in traceroute space /?. It gives you different options. What are the different options that we can add to this traceroute command? This is called as extended traceroute. So here you go. This is how it is actually done. In your privileged executive mode, type in traceroute, press enter. You can go for protocol. If you just simply press enter, that means if you don't want to give anything, it will automatically take its default addresses, default settings that is already have. So if you just press enter, it takes the indicated default values. If you want to change anything, then you need to enter whatever commands or whatever values that you need to enter there. This is called as extended traceroute. The next most important thing is something called as a network baseline. This is used for monitoring and troubleshooting network performance. Now, what do you mean by this baseline? If I want to compare something, I need the norm. I need to see what is usual, what is regular. That is called as a baseline. So for starting a baseline is to copy paste. So when you do a next ping or this traceroute command, you just simply copy paste all those things onto one particular file, text file, and you can timestamp them. And maybe later, if you find some anomalies, you can simply come back, check with these saved ones. By that, you can actually establish a network baseline. This is a common thing, very regular one. Whereas corporate networks, they should have some extensive baselines. They require professional grade software tools are available for storing and maintaining this baseline information. Cisco's best practices for baseline processes can be found by searching the internet for baseline process best practices. Just Google it. You can go to the necessary link and you will have a better understanding of creating these baselines. So this host and iOS commands will just come across this. We have done this earlier. So if you want to find out about your IP configuration on the host, you just need to type in IP config. It gives you a very good information or an excellent information regarding your IPv4, IPv6 addresses also. It gives you the default gateway command. All those things are done. And if you are using a DHCP client, you can renew your address by typing in ipconfig release, ipconfig renew commands. You can actually use ipconfig display DNS. It shows you all the cached DNS entries on a Windows computer system. Similarly, like Windows, we can use it ifconfig on the Linux system, and the same ifconfig command can be used for a Mac OS also. This we have done extensively earlier, so I'm not going to discuss much over here. Just go to the packet tracer activity videos. We have done extensively using the ipconfig and even the show commands video for this particular module, which is posted here. Just have a quick look there, you will be able to understand. Okay, then comes the ARP command, which shows you, which displays the known IP addresses and the MAC addresses binding. This displays information that have recently been accessed, but to make sure it is populated, just ping a device. It will have an entry in the ARP table. If you want to remove this, you can clear it. You can just type in NETSH interface IP delete ARP cache. So it will remove all the cache information from ARP. These are all the different show commands that you have been using in our previous modules. Show commands are the best commands or the best helpers for a network administrator to troubleshoot any issue. If you know which show command to use, I have created a video on working with show commands outputs, or how to interpret the show command outputs. You can check out in that video where we tried some of these show commands, and in order to troubleshoot one particular issue, which show command gives you the best output for you to understand it. All these show commands have been done from your earlier modules also. This is another called as show CDP neighbors, which gives you device identifiers, address list, port identifier, capabilities list, and also the platform of the device. So this is a show CDP neighbors detailed command, which can also be used. IP interface brief, I just told you, just go for the IP interface brief to have a quick, it doesn't give you a lot of information. It shows you which ports are up, if there are any IP addresses assigned to that post, whether it is up or down. That information will be provided here, and which ports are left unassigned. Troubleshooting methodologies. So obviously, whenever you establish a network, you will come across some troubles, maybe misconfiguration troubles, anything can happen. So these are the different, there are 6 steps. It's a kind of process. First thing is you identify the problem. This is the very first step. There are many tools that can be used, and you need to check what is the problem. So once you identify the problem, then you move to the step 2, where you establish a theory of probable cause. So you understand why this problem has happened, and then this step might actually give you different probable causes, not maybe one, maybe many probable causes for this problem. And then you test your theory to determine the cause in step 3. So test your theories to identify which one of these issues caused this problem. So when a technician may apply a quick fix to test and see if it solves the problem. If it does not solve, then you have to research the problem a little bit further and then establish the exact cause. Once you've done this in step 3, you can repeat for each and every probable cause that you identified in step 2 until you come to the conclusion that this is the problem, or this is the issue which has given rise to this particular problem. Then go to step 4. You establish a plan of action and then implement the solution. Step 5, verify whether once you implemented this has solved your problem or not, which gives you a verified solution, and implement preventive measures. So if it is successful, then what happens is you want to make sure that this does not repeat again. Most important step for me is step 6, where you have to document your findings, what you've done, and what is the intended outcome for that, so that it will help for your future reference sake. Any other network administrator facing the same issue can check it out, and it will help him a lot to troubleshoot the problem very early. Resolve or escalate. This is a common dilemma for most of the network administrators. If the issue can be resolved, they might go for it, but sometimes not all the solutions can be resolved by the network administrator itself. Sometimes it may need to escalate it up the management hierarchy, because it might involve financial causes. For a simple thing, if a router is gone, if some interface of a router or some issue with a router and it needs to be replaced, just a network administrator can't replace a new one. He has to escalate this particular problem to the upper level to get the financial approval, and then purchase a new router and then install it. So a company policy should clearly state when and how a technician should escalate a problem. Under what circumstances, what conditions are required to escalate these problems. Then comes your debug command. The iOS debug command allows the administrator to display the OS process, protocol, mechanism, and all the event messages in real time for analysis, but it gives you a huge amount of information. So to list a brief description of all the debug command options, use a debug command in the privileged executive mode at the command line. And if you don't want to do that, just simply type in the no keyword. That's all. And you can also enter the undebug from the privileged executive mode all. And if you want to turn off all the active debug commands that are being placed, simply type in undebug all. So you can see it gives you a lot of things. That there is also something called as terminal monitor command, where debug and certain either iOS message output is not automatically displayed on remote connections. This is because the log messages are prevented from being displayed on the VTV lines for remote connections I'm talking about. Now, if you really want to display these log messages on the terminal lines, what you need to do is you need to type in terminal monitor is the privileged executive mode command. You can see here terminal monitor if you type in, and to stop logging messages on a terminal, you just need to enter terminal no monitor privileged executive mode command. Okay, so this is what your commands in. There are other scenarios. We have to make sure that duplex operation and mismatch issues do not happen, because the auto negotiation feature does take care of most of your problems, but if it is not set, you need to make sure that both the ends are working properly. You can't see that one side of the connection is in full duplex mode and the other side of the connection is in a half duplex mode. It usually gives rise to a lot of other issues. Okay, and IP addressing issues, once again, we have worked on troubleshooting IP addressing issues in our earlier videos. Need to make sure you need to use the show commands to have a good idea. And default gateway issues should also be taken into consideration. Most of the times it usually works because if you misconfigure the IP addressing, the network administrators or the system people might not enter the right IP addresses. And there is something called as APIPA. We have studied this, automatic private IP addressing. If your Windows machine is not configured with an IP address, or if it is unable to contact a DHCP server, it will choose one from this particular given address range, and it is called as APIPA, but it will not be able to connect to other machines. So in that case, you just type in the IP config in your command prompt and check out whether the IP addressing is done properly or not. The same thing goes for default gateway. Sometimes most of the network administrators might forget to issue the default gateway in the switch or on your systems, and sometimes they might misconfigure the default gateway. If it is the case, you will not get network connectivity to the outside networks. So please make sure that the default gateway is set properly. DNSS is also, once again, you can actually go for DNS IP config all to show which DNS server is in use by your Windows computer. That should you should actually, if you want to change the DNS server, you can actually also configure it. So these are all the different troubleshooting issues with the DNS and your default gateways and your IP addressing. Ultimately, what you have to understand here is there might be many issues, or there might be many different reasons for which the network configuration can go wrong. It is ultimately the responsibility of the network administrator to troubleshoot these things. You have a lot of commands at your disposal, a lot of different tools at your disposal, but it is up to the network administrator to understand which tools should be used or which commands to use in order to tackle the problem. So with that, this is the last module. I'm going to post some of the packet tracer activity videos for these modules also, to just give you an idea about how to troubleshoot, what commands to use, or how to interpret the show commands output. Do check them. Thank you very much. Take care.